The rarity of diamonds was a myth.
A myth created by De Beers, a company that for a long time controlled the production of most of the world's diamonds, and which, as its one-time chairman said, increased their value by making them artificially scarce. But if other commodities are anything to go by, diamonds' value could drop quickly. Take aluminum, for example. Until the early 1800s, it was more valuable than gold. That's why it's on the top of the Washington Monument. And why Napoleon III served his guests with aluminum dishes. But aluminum was never rare, just difficult to make at the time. With diamonds, something similar is happening.
As far as man-made diamond production, that technology has actually existed since probably the 1950s or 1960s.
But for a long time, we could only make tiny grains for industrial applications.
But about 4 or 5 years ago, we started to see advancements in technology that allowed for production of gem-quality diamonds that are man-made and high enough quality to be used in jewelry.
Press that can achieve those high pressures that are equivalent to a couple hundred kilometers down in the earth, same as where natural diamonds grow, 5 to 6 GPa. And inside that press is this sort of apparatus, a heating cell apparatus that consists of heating elements to get the very high temperatures, about 1,000 degrees, a source of carbon, which is usually graphite or diamond powder, a metal solvent catalyst. And this is the key bit to let you grow at those temperatures and conditions, is having this metal, which is usually iron, nickel, cobalt, titanium. Different combinations work. But this area facilitates the growth of diamonds, and I'll explain that in 1 second. At the bottom, you have a diamond seed crystal. If you want to grow diamond, especially single crystal diamond, you need single crystal diamond for the carbon atoms to know how to bond effectively. So you heat this whole thing up, and not only do you heat it up, but you heat it up more at the top than you do at the bottom, about 20 to 30 degrees hotter up here. And what that does is the heat in general makes the solvent, the metal catalyst melt, and then the carbon dissolves into the metal and it migrates from the hotter temperature down to the lower temperature. It runs into the diamond seed, the single crystal diamond, the structure, it starts to bond and it starts to grow single crystal diamond. And you can see a nice little orange version here. And that's the gist of it. The whole thing can take place in a few days to a few weeks, depending on what and how large you're trying to grow. The presses, there are 4 different types of presses that are mainly used in the industry. I'm only not really going to comment on the details here other than to say that the most common one is the one that you see on the right. And it's called the cubic press. It has 6 anvils that point in the 6 different faces of a cube. In the center, you have this entire apparatus that I showed you here. And the pressure is equal in all directions to simulate this pressure deep in the earth. The reason I only show you this press is because this seems to be the press of choice. Companies like New Diamond Technology that are growing the very large lab-grown diamonds are using these presses. And a lot of the Chinese companies that are growing lots and lots of the tiny, tiny melee are also using these presses.